Hello everyone, my name is Sakit Reddy and I am presenting our project, the Multilingual Podcast Translation Service, alongside my teammate Navya. This project aims to make podcast content accessible globally by overcoming language barriers using cutting edge cloud based technologies. Now, let's talk about the goals we set out to achieve. Our project focuses on four key goals. First, enhance accessibility, allowing podcasters to reach global audiences by translating audio into multiple languages, complete with downloadable scripts. Second, we developed an automated translation workflow to handle speech to text translation and text to speech without manual effort. Third, scalability, achieved with Kubernetes to handle dynamic workloads and ensured consistent performance even under high demand. Finally, we focused on seamless integration and user experience with an interactive web interface. Having discussed our goals, let's move on to the and hardware components that power our project. Our project integrates a combination of software and hardware components to ensure efficient and scalable performance. We used Google Cloud APIs, including speech to text and translation for accurate audio to text conversion and multilingual translation, a Python GTTS library, which powers our text to speech service for generating high quality audio outputs. For communication between microservices, we relied on Google PubSub, ensuring a step by step flow through services like STT translation and Redis cache improves responsiveness by storing frequently requested results, while Google BigQuery tracks metadata and request statuses, and Google Kubernetes engine in which we orchestrated scalability and reliability. Finally, a virtual machine hosts the front end for smoother user interaction. Now, Navya will explain about the architecture components and their interactions, followed by our systems workflow.
Now let's take a detailed look at the architectural diagram and explain how different components interact and how the multilingual podcast translation service works. Let's walk through how it all works step by step. The user starts by interacting with the front end, which is hosted on a virtual machine, where users can upload their podcast audio files, select the source and target languages, and initiate the translation process. Once the user submits a request, the front-end sends requests to the backend REST API via an ingress controller, which routes them to the appropriate services. The backend is hosted on a Google Kubernetes Engine GKE cluster, where the system scales dynamically using horizontal pod autoscaling. The REST API serves as the entry point for all requests. Upon receiving a request, it generates a unique job ID for each request and sends a Redis cache for existing results. If there is a cached result in Redis, it's returned immediately. If cache is amiss, it uploads the audio file to the Google Cloud storage and publishes the job metadata, including the file URL, source language, and the target language, to Q1 in Google PubSub, initiating the backend process. From here, the backend microservices come into the play. Speech to text service retrieves metadata from Q1 and converts audio into text using the Google Speech to Text API, sending the transcribed text to Q2. The translation service subscribes to Q2 and translates the text into the target language via the Google Translate and sends it to Q3. The TTS service listens to Q3 and generates audio using the GTTS library and uploads the result to Google Cloud Storage, forwarding metadata to Q4. The BigQuery service retrieves the metadata from Q4 and stores it in a database and forwards it to Q5 for storage processing. The storage service listens to Q5, organizing the files in Google Cloud Storage, and sends metadata to Q6 for caching. The Redis cache service subscribes to Q6, encodes the results, and stores them for quick retrieval. Once all these processing steps are complete, as the front end is still polling the REST API for results, and the results are cached in Redis, they are retrieved instantly and presented to the user. Otherwise, the user is notified that the request is still being processed. Having discussed about the workflow, let's now go ahead and see the live demo of how we implemented on front end. Welcome to our demo of the multilingual podcast translation service showcased through our website, Podcast Translator. Let me walk you through how it works. Here is our user-friendly interface where podcasters can upload their audio files along with the source language and the target language. And it also lets you choose a dialect of the target language, if any. Let's now upload a file. Select the appropriate source language as English, and I randomly select Spanish with a US dialect as a target language. This feature helps address regional nuances, ensuring accurate translations. Once everything is set, we simply hit the translate button and the backend processing begins. While that's running, let me show you the backend logs for some of the services. Here is a REST log where you can see that the input is being processed and the job ID has also been generated. Let's randomly move on to the TTS log. You can observe that the audio has been completely processed and translated into the target language. From here, Saket will continue.
Hi all. Similarly, each backend process its task by retrieving data from queues subsequently and passing it along until the final results are stored in the cache. And here is another service pods logs. Here you can clearly see that in the BigQuery, the data has been added to the podcast metadata table perfectly. Finally, let's check out the output page. Here, you can see the translated text has been displayed with proper punctuation along with an audio player. Let me just play the audio.
Tenga en cuenta su fisiología y el estado de su cuerpo.
I
Lo que
can
es realmente fundamental.
I can even control the volume with the volume controller, and I can even uh, adjust the speed of the audio. And we even added an option to download the MP3 file. Here, as you can see, once I click the download button, the audio has been downloaded. Also, finally, we added a start over button in which once it gets clicked, it takes us back to the home page where we can upload another podcast. And that concludes our demo of the podcast translator.
Next, let's look at our debugging and testing approach, which was structured to ensure the reliability and scalability of our system. For local testing, we simulated inter-service communication using JSON to debug and refine workflows locally without relying on cloud services. For unit testing, each component such as REST API endpoints and caching mechanisms was tested individually for functionality. For error handling and logging, we implemented try-catch blocks for robustness and centralized logging to track data flow and identify any issues. For integration testing, we validated interactions between components by using message queues and storage services to ensure seamless communication. Finally, for end-to-end testing, we simulated the complete workflow to verify the accuracy and quality of results from user input to output. Now, Saket will conclude the presentation.
Our system is built to handle up to 10 concurrent requests, dynamically scaling with Kubernetes horizontal pod auto scaling. And on an average, each request is processed in 5 to 10 minutes, depending on the complexity. However, we find some bottlenecks. An API rate limits during peak times, backend delays for large files, cache evictions in Redis impacting responsiveness, dialect handling for less supported actions. And finally, for the future scope, we aim to enable real-time translation for live podcasts, supports additional formats like WAV and FLAC, and add batch processing for multiple episodes. Analytics dashboards for podcasters will also enhance insights into user engagement. So this concludes our presentation. Thank you, guys.
Thank you, everyone.